In this lesson, we're going to look at harder discriminant questions, which is really kind of approaching higher. I've never seen these coming up in a National 5 paper. That doesn't mean they're not going to come up though, because it is in the National 5 book. However, let's have a look at it. So these are kind of reverse questions, almost problem solving, like where you are given the quadratic function and there's a missing coefficient or a missing value in it, and we've got to try and use the discriminant to work it out. Now there's usually this mention of equal roots or real roots or non-real roots at the end, which will lead you into the discriminant idea. What you try to do in these questions is follow the same technique as you've done before. An equation results and you try and solve that equation to work out the missing value. So if you look at this, find a given that x squared minus 4x plus a is equal to 0, and it's got equal roots. So just start the same way as normal, get your coefficients. So a is the number at the front of x squared, so that's 1. B is minus 4, and this is a bit strange, but C is a, okay, because there's an a value at the end there, so that's what C is. Now for equal roots, we need to know our discriminant. So for equal roots, b squared minus 4ac is equal to 0. So this is where you set up your equation, which allows you to get what a is. So you feed these numbers in, so minus 4 squared, so I'm going to put that over there, minus 4 squared, make sure you put that in brackets, because that's going to become positive 16. Take away in a bracket 4 times 1 times a, and that comes to 0. And this is what we're trying to solve. And we should be able to do that because there's only one unknown value. Whenever you've got an equation and one unknown value, you can always solve it. So that's going to come to 16. So 16 take away 4a basically. And there's various ways to do it. You can just say take the 4a over and 4a is 16, or negative 4a is negative 16. And then a is 4. So there's your answer. The equation has equal roots when a is equal to 4, when that number there was 4. And you could check that. If that was 4, it would factorise, wouldn't it? And it would go to minus x minus 2, x minus 2 would be equal roots. Right, let's have a look at another one. So this time we've to find the k value, so I've put it in here this time. And again, we're using equal roots. So find k given that that has equal roots. So same thing, coefficient of x squared, 1. Coefficient of x, now that's minus 2k. Really important to take that minus. So it's minus 2k, and the c value is 5. Now when you're putting that in and you're squaring it, I always, like last one, I put it in a bracket. So it's minus 2k squared, because that's going to end up with a positive 4 when you square it. Again, these are things that are common mistakes that people do. Put the second bit in a bracket, and it's going to be 4 times 1 times 5 equals 0. Right, so that's going to give us 4k squared. And 4 times 1 times 5, that's 20, isn't it? So minus 20 equals 0. Now there's various roots you can take here. You could take the 20 over and then divide it by 4 and then square it at the end. I think I've factorised it here, so I've taken out the 4 as a common factor, and I've realised that k squared is equal to 5 to make the bracket equal to 0. But again, you could have taken the 20 over and divided by 4 to get down to this. Now to get k, we need to square root. Now what we have to remember here when we square root is there is positive values and negative values that work. Say it was 9 there, it'd be easier to understand. If you're to square root 9, you could have positive 3 or negative 3. So this is the questions that would say, give me 2 values that would work. So I'm just going to write it like that, plus or minus square root of 5. I'm not going to give a decimal value, I'm just going to leave it like that. But as I say, if that said 9 or 16 or 25, you just put plus or minus what the square root of that number. And if it's a number that doesn't square root, just leave it as a surd. Put plus or minus in front. So these are 2 values that work for that. Okay, last one. Find p given that 2x squared plus 4x plus p is equal to 0 has real roots. That's slightly different. Real roots. Okay, right. A is 2 in this case. B is 4. And last bit is p. Now for real roots mean the roots exist. Now there's 2 times the roots exist. That's when the discriminant is equal to 0 or greater than 0. So we're going to have greater than or equal to here. So that was a wee bit different than before. The rest fill in the information. So we've got 4 squared. And then 4 times 2 times p. So 4 times 2 times p is 8p. So I've kind of gone a wee bit quicker there than substituting it in. Again, there's various routes to take this. You could take the 16 over, or you could take the 8p over. I've taken the 8p over, added the 8p to the other side. I've then just divided both sides by 8, and then I'm going to write it the other way around. I'm going to flip it over like that. But you could have done various things. You could have taken away the 16 and get negative 8p is greater than or equal to negative 16. Flipped it around, 8p is less than or equal to 16 and divided by 8. Whatever way suits you to get down to the right final answer there. And there's your answer.